Good evening, students. How are you doing today?
Good evening, sir. Doing well.
Yes.
How are you, sir?
I am. Thanks for asking. I have seen better days. I am a little. I'm a little. I'm a little off because I don't like when I have in my classes and I have challenges to either to connect or students hearing. I had a little challenge for my other class just now, and normally I don't come in at this time. I'm always earlier than now, and um, so I kind of just feel a little off. But I'm giving thanks. Could have been worse. So I'm thankful despite. But thanks for asking. So clearly, Daniel, you and I are the only ones in class tonight because you're the only one that responded to my thing. So differentiation, we will get in all of it. We are okay piecewise. All right, so trust that you're all well, and I had given you, we started piecewise functions last class, and we went through the whole nitty-gritty of it. In a nutshell, piecewise is encapsulating both the intuitive approach and the calculations approach. Depending on the piecewise function that is given, you can get in the piecewise, you can get 2 functions, you can get 3 functions, you can get 4 functions, you can get 5 functions, you can get any number of functions depending on what the examiners want to send. So I gave you one question towards the end of the class with just 2 functions in it, but the ones that we were working with before had 3 functions. So remember, you're going to see the question will be asked to evaluate the limit at a particular point or points. We're going to be investigating those points, both left and right. If they are equal, then the limit exists. If they are not, then you'll say that it's discontinuous. When the limit exists, you say that it's continuous. When the limits don't exist, you say that it's discontinuous. So, with that said, I'm going to find me another example on piecewise. What is this? Oh, nice. Some actually finished with that. All right, some actually in unit 2. Fabulous. I feel like I'm moving. I feel like I'm moving. So, please. All right, so we looked at some rules. Did that question, did that question. Okay. All right. I'm sharing my screen now. I'm asking you to work on that doing for me. Tell me if you're seeing the screen.
Yes, sir.
Thank you. All right, just go ahead and just try that for me, please, as best as you possibly can. I want to see how well you guys are working on that one. Thank you. Are we okay so far?
Sir, can you repeat?
Repeat,
Are
please.
we okay so far?
Yes, sir.
I'm finished.
Are you finished? Nice job. All right. What did you get for your answer?
Sir, for the -2, I got +1 and -9.
Sir, +1 or -1.
That's what I get for -2, sir.
So
Positive
is
one,
it
negative.
is it continuous or discontinuous?
Discontinuous, sir.
Discontinuous.
Okay. And then the other one is what?
+2 would be -1 and -1.
So continuous or discontinuous?
Continuous, sir.
Everybody got that?
Sir, I never worked with the second one.
All
Sir,
right.
Yes,
for the-
sir.
All right.
for
Thank
the
you guys.
first-
Go ahead. Somebody saying I hear the yes, but somebody was saying
Come on,
for the
sir.
first.
Yes, sir, for the first one, sir, where they did it with a -2 on the square, how did they get negative? How did they get +1 for the answer?
Look at it. It's on the screen. Look at it and then tell me if you see what is happening. If not, I'll be more than happy to go through with you.
Sir, can you speak a little louder?
No, sir, I
can't hear.
can't. No, sir, I can't see it.
You can't see.
No, sir. I think I'm
Sir, for the first
mixing up.
Are you seeing it better now?
I think you meant you didn't understand.
Oh, you're not understanding what is happening. All right, no problem.
Yes, sir.
That's what Daniel. That's what you meant.
No, sir, Leon, for that second one,
Oh,
sir.
sorry.
For that first one,
Oh, still, you're not seeing what is happening here. That's what you're saying, right?
no, sir, because I got
All right,
that.
no problem. No
Yeah, man.
problem. All right, so let me go
Sir,
through.
he
it again.
said he got 9. I think it's more with the calculations, right then?
Yeah, I think it's, I mean, I'm
Calculation. I just
miscalculation
because I was getting that here.
as well.
Okay, all right, fine. Now, one of the ways about teaching is not for me to just jump and do the solution. I want to hear the mistake that you made in order to get that 9, so I can correct that incorrect.
Okay,
so
so
tell me.
all right, sir. At time, because of the square sign at the top, sir, at times the -2 and the -2 times to by itself, and I
Okay.
got yes, sir.
Oh, and you got -4 when you put it in the calculator.
Oh, sir, I put +4. That's why.
So what you did,
Okay, sir.
you put
My mistake.
-2. You put no, hold on, man. I just want to find out what it is that you've done because it's very important. It's very, very important. I think, as a matter of fact, you were the only class that I have in the week. So, earlier. So I think you're the ones I was teasing about cheap calculators. I hope you are the group. So Leon, you're saying to me that you put in -2 on the calculator squares and got -4 and -5 and got -9. Yeah,
sir,
no?
No, sir, I put +4 and I got 9, -9, something like that.
Mathematically, what you're saying there is not sound. All right, press pause. I heard Lottie coming in. Tell me how you got 9, Lottie.
I don't think it's Latin this time, sir. I got -1.
Okay, who was that? Sherry? Who?
Utterly helping him out. I'm not sure.
Okay,
Sir, I was
sorry.
telling you that when I was calculating it, I didn't use any calculator, but I was just saying -2 times -2. Then I remember, oh, negative times negative give me positive. So this I'm gonna correct my error and say, all right, a +5 -4 will give me a 1, -1.
Sorry, -5 you mean, not +5.
I'm negative, yeah.
Right. So I guess what you're saying, you're saying that you are saying -2 times -2 give you -4, and then you correct it yourself.
Yes.
Okay, so that makes a lot more sense. Leon, I'm coming back to you now. tell me how you are getting. I need to know where you're getting a -9, you know, because if you don't tell me, you can go back and make the same mistake, and I don't want to make that mistake again. Because what I thought you were doing is what Arthur Lee says she was doing, because that is obvious. But you are saying that's not what you are doing. So you need to tell me how it is that you are arriving at the -9.
Sir, I don't remember if I put it in the
Were you
calculator.
using a calculator?
No, so I'm using my phone. The calculator on my phone.
Were you using a calculator?
No,
Say
sir.
yes. Say yes. You're using a phone. You're using a phone calculator. True or false?
Yes, sir. That's the one I'm using.
Yeah. And I'm saying, okay, no, you can't do that. So when you put, I don't know if this was a group of stuff and I'm talking to, but when you put your cellular phone is one of the worst devices to do mathematical calculations of this level. It's not built in with syntax construction. It was this class because I think the other person, I think Courage was saying math error. Okay, scrap that. Do me a favor now, Leon. Scrap my explanation. Do me a favor, Leon. Go back to the calculator now. I mean, your cellular phone, because it's not a calculator. Open your parentheses on your cellular phone.
Yes, sir.
Put in -2 for me.
Yes, sir.
Close the parentheses.
Yes, sir.
Square it.
Hold on a minute.
Can't find the square now. Look for upside down V if you can't find the square sign. Just look for upside down V. And when you find the upside down V, if you see the upside down V, then
That's
you're,
right,
you
see
see?
the square sign. Yes, sir.
You see the square sign, yeah. I'm -5 now. And tell me what you get.
-1.
Aha. So you were using a calculator, but you weren't inputting the information in the calculator correctly. Let me tell you why I stopped the class to talk about this. I taught a group of calculus students, I think it was calculus 2, when they were doing an exponential function for me using Maclaren's. Try as I may, I come to the class and I show students how to use their calculator. If you tell me a version calculator that I don't know, I said, take a picture and send it in the group so I can see it. And a number of students, well, I kind of know what was happening still in the class. A number of students gave me the same incorrect calculation of the stuff. And I know why. Because they were raising the exponential function to another function without using their parentheses. And everybody was getting the same incorrect answer. Just a few students in the class were using the correct stuff. So I knew what was happening, if you know what I mean. I knew what was happening. And it's very important for you to know how to maneuver the calculator, be it a cellular phone calculator, or a physical calculator, or a calculator on your tablet, or any other device, still calculator. All right.
Sir,
Yes, please go ahead.
I got the answer correct. My issue is the theory behind it. I wanted to I do the calculation part, find everything, but I just wanted to know, how do I know which one of the functions I'm supposed to be using? Because I was just doing it.
All right, so you missed that session. All right, let me go through with the second part of the question to answer your question. Thanks for your question, Shelly. That was Shelly, right?
Yes, sir.
All right. Dane, I would love for you to unmute and speak to me in class, please. Thank you. All right. So before I do that, though, let me ask a question. Somebody said to me that the other one was continuous also. What was your value?
So you can repeat that question. I didn't
So
hear.
what was it for positive 2? Was
Sir, the
positive 2
same.
continuous?
Sir, for the positive 2, I got -1 and -1. So it's
It was
continuous.
continuous. Very good. Everybody agrees with that?
Yes, sir.
All right. Is there, I'm coming to you, Chetty. Don't think that I'm leaving you, Chetty. I'm coming to you. I'm coming to you. Question. Is there anyone in the class that
Yes,
didn't
sir.
get the second one right? I hear somebody coming in. Who is this?
Ashanti, sir.
Yeah, yes, we did. Go ahead.
Sir, I said it's continuous.
Good job, honey. Very nice, very nice. Dane, can you unmute for me, please?
Yes, sir.
What did you get for the answer, Dane?
All right, I'm going to be honest. I'm not working on this one, sir.
Why think I call on you, Dane?
Because I'm not paying attention, sir.
Thank you very much, Dane. Thank you very much, Papa. Do make a follow with you, Papa. You're Dane? Hello, Dane.
Answered, sir. Yes, sir.
Oh, I didn't hear you. Sorry, I didn't hear you. All right. So I'm going to say it to you. So if you know me, I'm a very high achiever. I'm a very high achiever, and I put my students under a lot of pressure because I'm expecting the best of you. I do not want any of you to take this calculus 1 for granted. There are some topics that are going to sneak upon you like a thief in the night that is going to give you headache. I'm telling you straight up. I teach a course I know, and I was once a student having to learn it. I want you all to focus on what is happening. And I'm going to say again, I need you all to talk to me. Finally, before I continue, there will come a time when I will teach and I will say, are you understanding? And maybe the lone student who is understanding say, yes, sir, and I'm going to move on. Knowing well that there are some of you there who are not following, but I'm telling you, I'm giving you the responsibility to ask me questions. Very important. That's what you learn. So there will come a time, and I ain't going to ask you, are you understanding? And I stop and ask everyone in the class. All right? But guess what? It will show on my mid-semester, which is fast approaching. I've given you so much information already that you can almost do my mid-semester exam. All right, so let's go. So Chetty, you're saying that you need a little theory behind it. All right, an opportunity, Dane, needs to focus, and the rest of you. An opportunity to see what is happening. So let's go from up top, because we're going to be using this as a platform to do a little bit more work tonight. Determine if f is continuous at x equals -2 and x equals 2. Given the piecewise function, 3x plus
First,
7.
enter your password to unlock the device.
You see? When I want to activate you, you're not playing your mind. I know I'm not talking to you, you're answering me. The piecewise function, 3x plus 7, such that x is less than -2, and x squared minus 5, such that x is greater than -2, but less than or equals to +2. And then 5x minus 11, such that x is greater than or equals to 2. So we need to investigate if the function is continuous at x equals -2. So what we're going to be doing is and this is what I want to say to students. What I want you to do first, we're looking at -2. So you're going to write on this stuff. You're going to write limit as x tends to -2 to the left, and the limit as x tends to -2 to the right. So you're gonna write, a line. If you want, you can write it side by side, one here and one over here, however you choose. All right. And then you're going to use here. I think I find it much easier to explain it this way. So I'm going to go this way as a second way of my experience class. So you're investigating the limit as x tends to -2 to the left, and the limit as x tends to -2 to the right. You know that you're looking at when x is equal to -2. See right here, so it says at x equals -2. So you know you're investigating it at x equals -2. Now you're going to ask yourself a question. Which function within the piecewise function deals with x to the left of -2? Which function in the piecewise function deals with x? And I want you to listen to my question now. Cherry, come. Dane, listen. X is to the left. Remember, -2 with a superscript minus sign is to the left. With a superscript plus sign is to the right. So the limit as x tends to -2 to the left. Watch this now. X tends to -2. Can I use this equation any at all?
No, sir.
No, sir.
Tell me why.
Because you don't have a negative in it.
Excellent. The condition here says x is greater than +2.
Yeah, +2.
So the only functions I can use is the first one here, 3x plus 7, and this other one here. Yeah. But it says to the left. Which of these? So since I ruled out this one already, I mean, no, say them two you have to use. Tell me now which of them two your deal is to the left.
X squared -5, sir.
Why? Tell me why. Tell me why. Tell me why I say x squared to the -5 is dealing to the left. Háblame, talk to me.
Sir, it's coming from the left. X is coming from the left, so, and it's going to the right, I guess.
All right, done, but that don't help me. That don't help me. Yeah.
Sir, can you explain the left to right thing with the X?
You can't explain it now, because it your ass. Me still talk to you. Come on, guys. So
Sir, I think it's 3x plus 7.
Why?
Because the negative is on them.
Because x
Sir,
is
because the
less than
negative is greater than the right side.
All right, go again for me, please. I'm coming to you. Go ahead.
Because the left side is greater than the right side.
Because the negative is on the left.
Sir.
Yeah.
I would say 3x plus 7 because the x has to be less than the -2. So you're going to the left.
Okay, Mr. Rowe, let me hear what you're saying, Mr. Rowe. So, Rowe, you were saying something to me earlier? Are you guys hearing me? Am I being heard? Am I disconnected?
So we're hearing you.
So, Rowe, I'm waiting on you. You were explaining something before. I want you to go back to it.
Oh, sir, I couldn't hear you a while ago. I was saying that I think it's 3x plus 7 because
Mhm.
the x is less than -2, so it's to the left.
Thank you very much. Now, Lottie and Chedi, I'm going to ask him to say it again, and the rest of you are going to listen.
Yes, sir.
I heard that coming from him, which is why I waited. I'm impatient to say it again. Joe, you asked a question just now. I want to listen to what he's saying. I don't like it that is on the left because I can rewrite that inequality where the -2 is on the other side. If you
Okay.
see what I'm saying. So
Yes,
put it
sir.
this way. So I say that there are only two institutions on North Street, the Gleaner and the Kingston Public Hospital. And somebody can say, no, sir, you missed the program because you're up
Left the
on college.
purpose school.
Yeah, and I'm going to go on and say, no, so you missed the program and right there. And then now I will say, okay, if you're talking about a school, there's only one school on North Street that is on the right-hand side. And then somebody will say, sir, right-hand side, going which way? And then I will tell you which school is that. So that's the point I'm making. So you can say, oh, you know, mute. Tell Jaden say must carry math will come. So what you need to recognize is I can go on the right-hand side. From which direction? I can go from the left-hand side. From which direction? So it could be the right-hand side if I'm going from north. Then it can be on the left-hand side if I'm going from south. So that's why I don't know if you see the point I'm making, Chedi and Lottie, that I don't like it because it's on the left. Because
yes,
I can put it on the right-hand side and it still is the same thing and it throws you off. So Sir Ro, go again for me, please. I want the rest of you to listen. Go again, Sir Ro.
It would be 3x plus 7 because x is less than -2. So it would be on the left. Towards the
No, say no left, no, say no right. What is important is that x is less than -2. That's what it is important.
Okay, so yes.
Right. So that's what's important. So x is less than -2. So what I'm saying to you, I can reverse that inequation where it seems as if it's something else. Seems as if it is something else. Hold on, let me just plug in this other device and bring across the point that I'm trying to raise. I'm not just teaching up on a pass a course here. I'm not teaching us so that we can fully learn something, but it can't follow. Especially when you're going to the exam. Another question a different way, you still know where to go. So this to the left, to the right, and this is why I don't normally teach it with the alligator mouth open. In my notes, you will see me write something about the alligator said something there, and I only did it because some students said that to me, but I don't use the alligator, I don't like the alligator something. All right, watch me. You know, whenever the spotlight is up, this thing just take a while to respond. All right, watch me. Read that inequality for me, please. The one that I just wrote. Oh, sorry, I used gray. I should have used another color. The one that I just read that for me, please.
Greater than x.
Always start to the variable. It makes more sense when it starts to the variable.
Oh, sir, when I said x is to the left, I didn't mean like in relation to the -2, you know. I mean like on the number line.
Oh yes, Papa. Yeah, man. Make buy a soda. Oh, I'm very proud of you.
Yeah, that's what I was talking about, sir.
Yeah, man. But this when you talk about, you must say to the left of the number line, not just listen to me. Put it this way, Mr. Rowe. You walking past your minister of your church, and you want to say, for example, rock stone. And you say rock, and you see the minister and you stop, wait till the minister when think you can say, don't tell me no, you know. But it could be construed that you're going to say something else. Talk truth.
Yes, sir.
Yeah, because they let your conversation in flight. So somebody can say, oh, this is what you're going to say. But no, I was going to say rock stone. All right. So, yeah, man, if you're going to say to the left on the number line or to the left of 2, -2, which would be a better thing to say, to the left, not just to the left, but to the left of -2. Yeah, man, full 100. So read that one for me, please. I just wrote in pen. I just handwritten. Lottie, read it for me, please. I have to call upon people now because nobody is taking the initiative. Lottie, read that one for teacher and tell me what to get. Always start with the variable, it makes more sense.
-2 is greater than.
Start with the variable x.
X is less than -2.
Very good. Very good. Always start with the variable. Because when you say -2 is greater than x, that don't mean nothing to me. And I'm sure it does not mean anything to you. But when you say x is less than -2, so both of them are saying the same thing. It's just that the convention, how it is that this is written. So one is written in a more friendlier way to read as opposed to the other. The one that I just wrote. If somebody give a letter to them and say, Lord Jesus, what would they mean by this? But it's the same thing as the one that is typed. Always read from the variable. X or Y or whatever the variable is. Always read from the variable, please. You see, when you become a little bit more mature mathematically, then we can read it from anywhere else. But for now, read from the variable. It's like you riding a bicycle with training wheels. After a while, you may take up the bicycle and start riding, and the training wheel may just drop off. I don't even know the training wheel drop off because in your headspace, you have something that is protecting you until you recognize. I even recognize it. Sometimes I remember when I was learning to ride. Are you holding the bicycle? Yes. You're still holding it? Yes. And I recognize that the yes is getting further and further and further away. And me, I ride all right, you know. I say, riding the bicycle? You holding on the bicycle? I mean, you're not answer. I may turn around and recognize that nobody not running. Say, you know what happened next? Tell me what happened next.
Drop off on the bicycle.
Never drop off of the bicycle. I didn't know that I was doing this on my own. But the mere fact that I don't have somebody hovering over me, I believe that I'm doing it wrong. And we need to get past this. We need to get back past this stage. All right? Let's go. So, Chetty, your turn again. Lottie, and the rest of you. So, when we look at let me just put at my spotlight so that I can. So, when we look at the function, we want something to the left. Do you hear what so Rose says? It's to the left of -2. To the left of -2 is what we are going to denote as -2 to the minus. So I know which function deals with to the left of -2. All right? So it's going to be 3x minus 7. Sorry, 3x plus 7. Now, what I'm going to be doing, I'm going to assume that x is equal to -2. I'm assuming that x is equal to -2. I'm substituting that assumption into the function. Anywhere in 3x plus 7, I see x. I'm going to substitute -2. See here? 3 times -2 is -6. -6 plus 7 is going to be +1. And that's why I get +1 here. And of course, if that one is to the left, let us check the one to the right. We know the other one has to be to the right. But let us check. Watch me. X is greater than. It's why I say we must always read from a variable. Because somebody can read this and say -2 is less than x less than or equals to 2. What does that mean? Nada. Nothing. Zilch. Inside out. Inside out. From the middle to the left. From the middle to the right. This one is saying that x is greater than -2. Once it's greater than, it's going to be to the right. Once it's less than, it's to the left. Remember, I did say to you, less is L, left is L. L goes with L. All right? So this one is going to be to the right, x squared minus 5. So that's the function I'm going to be using. X squared minus 5. Similar argument. Wherever in the function I see x, I'm going to substitute -2. So -2 squares, and I've gone through this one already. So -2 squares is 4. 4 minus 5 is -1. Since the function to the left is not equal to the function to the right, then f of x is discontinuous at x equals -2. Sir, you may have to write that statement. Absolutely. That is you answering the question. What you did before was testing it. Now what do you do? So if you leave the question up here, so you have not drawn a conclusion, you have not answered my question. You've only tested it. You no need to write and tell me the function is continuous, the function is discontinuous because this is not equal to that or that equals to that. Right? So this part is very important. You don't have this part, you can lose mark. All right? Similarly, we're looking at x equal to. X equal to. I'm going to look at the function. Which of the function here? These with x equal to. Can I use the stop one?
No, sir.
Because why?
Because
You don't have a +2, sir. It's negative.
Very good, very good. The question may sound redundant for some of you, like, "Duh, sir, don't you see it?" But there are some students in here that are not making the connection. This one has a -2, so I know I can't use it. So my functions are here and here. Now I want to know which one moves to the left of -2 and which one moves to the right. Now the mere fact that this is x greater than or equal to, that means I want to move to the right, the 5x minus 11. And this one says x is less than or equals to 2. So once it's less than, it's to the left. So x squared minus 5 is going to be to the left of 2. See here? X squared minus 5 is to the left of 2. And 5x minus is to the right of 2. Now, when I go through and I assume that these values are my x variables, and I substitute, I end up getting the same value. Now, since the limits are equal, then f of x is continuous at x equals 2. Are there any questions? I'm building for something, you know. I'm building. Are there any questions? Okay.
Yes, sir. I have a question.
Go ahead, Papa.
Sir, is this the right side of the function?
What do you mean by the right side?
I mean that x is, well, to the right in the number line, going in the right direction.
Well, to the right of the number line is positive. And,
right.
Go ahead, Papa.
From -2.
Say it again?
So it's going from -2, or is the limit, as the limit change overall? No longer -2.
Oh. All right. Now, this -2 is going to be -2 to the left. That is the left-hand side. -2 to the right. So anywhere going this side. So if this is -2, that means say, and done. Or trace is supposed to be -1, talk truth.
Yes, sir.
And or trace is supposed to be 0, don't it?
Yes,
and then 1, 2, 3, 4, 5, right? So that means the right is positive. That's why I have this positive sign here, because going to the right is positive. But after -2, or to remember -3, then -4. I'm actually getting smaller, and that small is going to be a negative sign. So when I speak to the right, it means even if I am starting at a negative number, to the right of that negative number is always a bigger number, because -1 is a bigger number than when compared to -2. So whenever you hear me speak about to the right of, it means that it is going in the positive direction, even though I am on the negative side. That's just my starting point. But what direction am I going in? I'm going into the positive direction. So it means that I'm going x is greater than. If I'm going into the negative position, that means x is less than. Does that clear up what you asked, Daniel?
Yes, sir.
You sure?
Yeah, I'm sure.
All right, cool. Are there any other questions? All right, let's go. I don't want you to work this out on paper just yet. We're going to work this out in our heads. You can write on the question here, but I don't want you to work it out. We're going to do some mental mathematics. It says determine if f of x is continuous at x equals 1. Given that the function, the piecewise function is 6 minus x, such that x is less than 1, and 2x plus 3, such that x is greater than or equals to 1. Is the function continuous? What happens to the left of 1? What value do you get to the left of 1? Anybody, somebody, quick and fast.
5, sir.
Very good. Excellent. What value do you get to the right of 1?
5, sir.
5, sir.
So therefore,
It's continuous.
Continuous.
do easy 1, 2, 3. Easy 1, 2, 3. So what I'm saying to you, and a question such as this, when I'm not getting a question like this, I easily see this, and I get this. I want to put that here because I want to build the confidence. Because I'm actually building you for something else to come. And what is to come is going to cause you to do a little bit more, and you have to fully understand the area. It's going to require a little bit more knowledge to do that question. All right? But not to scare you. Let me go through. Do I have the solution here? I do. Praise the Lord. It asked me if it is continuous at x equals 1. Remember, I must look to the left-hand side and I must look to the right-hand side. I'm looking at the left. I'm moving from the left to the right, and I'm moving from the right to the left. So in investigating to the left of 1, it's going to be 1 superscript negative sign. See it right here, so. And the function that leads to the left of 1, see it here, so x is less than 1. Less than is to the left. So it has to be the function 6 minus. Then, sir, what if we know the two functions, but we mix up the functions, you will get it wrong. Because if you mix up the function, you have to get it wrong. Because you have to use the correct function. And you would know that because if you don't apply if you apply an incorrect formula to something, your result is going to be wrong. So let's go. So to the left of 1 is 6 minus x. Anywhere in the function you see x, you're substituting 1. 6 minus 1 is 5. Boom, put it down. Then to the right of 1, see here, I tell you, to the right of 1 is x greater than. Greater than is to the right. It is moving this way. And if you look at the inequality sign, if this inequality sign is open this way and it's very windy, this is the direction this is going to go. So this is telling you, the pointer is telling you which direction this is going. This point is telling you which direction that is going. So this one clearly you can see is going to the left, and this one here is going to the right. Anybody can see that? Hello? Anybody? Somebody?
Yes, sir. It's like the number sign is pushing x further from 1.
Very good. Very good. So the inequality sign, not number sign, the inequality sign. So the inequality sign is pushing this variable here further away from 1. So it can go, so it's a greater than or equals to 1. So it can be 1, but it can be 2, it can be 3, it can be 4, it can be 5. They say x is less than 1. It can't be 1 because there's no equal sign. So that's a 0, negative 1, negative 2, negative 3, negative 40, negative 40, 17, negative 50, 17. Yeah, man. All of them numbers on here, so way back on here, so. All right. Now, the mere fact that you know that it's going to be 2x plus 3, and you substitute your value, 2 times 1 is 2, plus 3 is 5, since the function to the left and to the right are equal, then the function is continuous at x equals 1. I'm going to ask a question. Are you understanding, class?
Yes, sir.
Yes, sir.
Is there
So
anyone in
far,
the
sir.
class? Very good. Is there anyone in the class that is not understanding? Or you're understanding, but the understanding is coming. It's not so 100, but it's about a 90 or even a 70. Anybody?
Yes, sir. It's coming. It's coming, sir.
Come in. All right, good. Yes, Dean. Go ahead, Papa.
No, I was just responding. Not fully there, but I'm going to watch over this and just get
All
the
right.
concept. Yeah.
And that's it. Oh, thanks for talking about something. Have you been seeing the recording?
I
Yes,
tried
sir.
looking for them, but I didn't. I'm seeing it some different stuff.
No, man. All right. So it's one channel that I have, but all the courses that I teach, I drop them in the same channel, but all you need to look for is Calculus 1, Math 3601, Calculus 1, Semester 1, 2022. If you
So you
look
can
in
send the link in the group.
no, it's in the YouTube, in the YouTube channel.
Oh, you said the WhatsApp. Oh, so
Yeah.
this.
So look in the description, I see my channel, click on it, and all the recordings for this semester is so labeled. If you want to find a Calculus 1 from another semester, you'll be able to find the same Math 3601, Calculus 1, Semester 1, 2021. That is last year, this time, and I taught the course. So if you want to find the ones relating to, just look for the 2022, Semester 1, 2022. The recordings are there, use them up. And if you want, I give permission, go to the channel and look for the other Calculus 1 and go through. If you have time, you can go through ahead of me. Who to tell, maybe I would have explained it better then, or maybe I'm going to explain it better now. All right, let's go. Very nice. Thank you, Lord. On your mark, get set, go. I want you to start this one. I don't want anybody to say, sir, me don't know. Oh, if we work for the x squared minus 1 over the x minus 1, walk the something. Walk the something. All right? Start for me, please.
Sir?
Yes, please.
Just one quick question. When is it I'm working on one of them. Is it we do it the working on like when we're doing like the difference between two squares?
Very good. Excellent. That's what we're talking about. Obviously, finish?
Yes, sir.
Yes, sir.
Good job.
Yes, sir.
Who's still working?
Yes, sir.
Where's Crosswell? You're not in class tonight?
No, man, he sent you a message, sir, to saying that his internet is giving him.
It was Crosswell. All right.
Yes.
You see that, thanks. It's one of the things that I am going to ask of you. Just a very humble request. You don't have to do it, but it's just a very humble request. It's like when you look at my WhatsApp, it says teacher S. So at least I know it's Mr. Shan. But sometimes when I have some
Crocodile.
yeah, so I don't know who it was. So I saw the message, but I didn't know who it was. So I don't know, maybe for that was a purpose. If you can keep what it is that you have, but at least put your first name or last name, so I know exactly who. Because there are times I want to speak to somebody directly, and I could just go in the WhatsApp and try the person. But when I have pretty girl this and hot boy this and chacha this and yeah, I don't know who is who. So yeah, I did see that message coming in earlier. All right, let's go. Let's go. Do I have this worked out? At x equals 1. What is after the x equal 1 as a matter of fact?
Sir, product I got 2 and 5.
You get 2 what?
2 and 5.
2 and 5. Oh, you got 2 and 5. I got you. Anybody got that?
No, sir.
Those I got 0.
2 and 1.
So we get 0 and 2.
I got 0 and 2. Yeah.
Do me a favor. All of you, do me a favor.
I got 0.
Every one of you. I hear you. I hear you. Every one of you. Every one of you, I want you to do me a favor. I want you to take a little time. I'm going to give you 3 minutes. I'm going to step away for 2 seconds, but I'm going to give you 3 minutes to look through my solution here. I know the other part is fine, you know.
So I
Oh,
did
so,
the other part first. I did 2 first. So I'm just working on the last one.
which one you did first? You did 2 first?
Yeah.
All right. So let me go to 2.
One.
Let me go to 2 because everybody can get 2. I'm positive.
I
Wait, say
get-
2 and 1?
Yes, sir.
I get
You get
one.
two?
I get 1 and 2.
7 and 7 for 2.
Come on, 7 and 7.
Yeah, 7 and 7.
No man, down there I get 7 and 7 down that side. They
Oh,
one
yeah,
of the
yeah. Oh, yeah, that's what I'm.
Alright, so that was easier to write.
Yeah,
Yes, I
man,
get
that's
that
what.
to be continuous. Yes,
Yeah,
sir.
man, yeah, man, yeah,
Let's
man.
continue.
That part is not a problem because it's a straightforward function. But the mere fact that you see a rational function now in a piecewise equation, it complicates matters. So the straightforward polynomial functions are fine. But you get a rational function, it will throw you off. So do me a favor, I'm going to give you 3 minutes. I will come back and I'll go through it now. But I want you to look at it and I want each of you. Can I do this?
Go with the question. Go a little more so we can see.
Yeah, I want, that's what I want to do. I want to.
Yes.
I'm going to leave it like that. I'll give you about 3 minutes and you'll look at it and identify the error on your own. And when I come back and I ask you, you're going to say, sir, this is what I saw, this is what I did, but I should have done this because I want to know where the deficiency is. All right? Stepping away. Stop.
Sir?
All right, that was a little bit more than 3 seconds. Obviously, all right with it now? See errors?
Yes, sir.
Nice. Anybody who still don't see their error yet? Utterly very good.
Good night, sir.
Good night. Who's this?
It's Atara. I just want to know what happened to the -1.
Which minus
At the
one?
top of the equation, say x squared -1. What happened to it when it move over there? Sir?
Oh, we factorize it. It's a difference of 2 squares. I was just about to say. I was just about to say congratulations, awfully, because she said, "Sir, is this the one with the difference of 2 squares?" And I said, "Yes." So look at what happens. X squared minus 1. When I factorize it to Tara, x squared minus 1 is when they give me x minus 1 times x plus 1 because it's a difference of squares.
Okay.
And then now this one, this x minus 1 in the denominator cancels out the one in the
Yeah,
numerator.
cancel out that one. Okay.
Right. I'm just left with x minus 1. Yeah. I think
Sir?
I did this very example earlier. Go ahead, please, Joe.
Okay. Sir, can you go again on how you got to for the first one?
How about 2 in terms of what? Do you understand the cancellation here? You understand
Yes.
the difference of squares, right?
Yes, sir.
And then you understand me canceling out this x minus 1.
Yes,
So
sir.
now that I've isolated what is prevented, remember now, this one here is 1, extending to 1. So when you substitute 1 into this function, you have 1 minus 1, you have a 0. You can't have a 0 existing in the denominator. So let me have a 0 right there, still something is wrong. That's a red flag. So it's indeterminate. It is indeterminate. So because it's indeterminate, one of 3 things: factorization, a simplification, or a rationalization. And I'll be my factorization because I recognize it's x squared minus 1, the difference of squares. When I factorize x squared minus 1, I'm going to get x minus 1 times x plus 1. And when I do that, now what I'm going to end up with, I'm able now to isolate or to cancel out the x minus 1 in the denominator that was given me 0 with the x minus 1 in the numerator to be left with x plus 1. Anywhere in the function x plus 1, I see x, I'm putting 1. Why 1, sir? Because the limit is tending to 1. Why not negative 1? Because it now the negative 1 to go to positive 1. And 1 plus 1 is equal to 2. And to the right of 1, how we know it's to the right of 1? Watch this now. X is greater than 1. X is moving away from 1. So I'm going to have 5x minus 3. Anywhere in the function I see x, I'm going to substitute 1. 5 times 1 is 5. 5 minus 3 is 2. So since both limits are approaching the same value 2, we say that it is continuous. Question. Okay, there's none. Very good though. All right, so we're going to begin our first past paper question in class. This is past paper December 2017. It says, oh Lord, I'm Father here. You know, I recognize that this thing won't work so well in this. No, it's not responding. Oh, come on. All right. A function f is defined as follows. See it yourself. You know what I'm going to do? Sorry, I'm not very anything. So how on earth did we get here from what it is that we have just done? All right, let me explain. And these are the type of questions I'm expecting. Is all that I did before was just the basis of it. Those are for like the students who are doing like business calculus. But for you guys you know, no, matter of fact, not necessarily no, because I do give my business calculus students these types of questions too. Let's go. A function f is defined as follows. F of x is equal to 2x squared minus 4x minus plus 2. X is less than negative 1. Ax plus b, x is greater than or equal to negative 1, but less than 1. And 5x plus 7, where x is greater than or equal to 1. Determine the values of a and b such that f is continuous over the interval x is greater than negative infinity and x is less than infinity, positive infinity. Oi, sir. You want to take into consideration every single value of x. So at all times, when you evaluate a and b, that function is going to be continuous every single time. Every single time the function will be continuous. There is no aspect when you find the value of a and b, there's no aspect, no time at all where it's going to be discontinuous. All right. Let me see now the ones who are truly learning and understanding. Work with me. Work with me. What should happen at x equals 1 and x equals negative 1? If I want a function to be continuous, what should happen at x equals 1?
Or 12. 12. The function of 5x plus 7.
Okay, fine. Okay, so all right. So you worked out x equal 1 and you worked out the second equation and you got 12. So what should happen? And that is to the right of x. What should happen to the left of x? Come on, man. You start off very good. So come work with me. Don't leave the hang in there. You are saying to the right of x, the function is supposed to be 12. I agree with you. I agree with you. Tell me now, what should happen to the left of x? The left of, the left of one. Sorry, the left of one. What should happen to the left of one?
Ax plus b.
Yeah, what happened to that one? What that's supposed to equal to? Well, ax plus b must equal to utterly and others.
Work it, sir. Work it.
Work with me.
Let me get the question properly.
All right, so let me ask the question again. And we're basing my question. My question is based on what it is that we've done since last class, and all that we're doing now. So, who was that? Was it Leon? No, who was it? Anyway, somebody said earlier about 12. They came up with a magic number 12. And I'm saying to them that I like the sound of that number 12. Because I'm asking, how do we investigate that x equals 1? And my goodly student says, okay, to the right of 1, sir, we're using the function 5x plus 7. And if x is equals to 1, we are assuming x here to be equals to 1. It's going to be 5 times 1 is 5. And 5 plus 7 equals 12. Sir, somehow the number 12 is floating. And then Ottilie says, sir, ax plus b to the left of 1. Yeah. What is ax plus b going to be equal to?
Sir, 12.
Why?
Sir, what you saying?
You said a while ago, sir, 12. And I'm asking you why.
But sir, you say continuous, you know, so.
No, I come in utterly because Miss Smith.
Sorry.
No, don't think that I'm ever very tell you say talk too much. No, I want to hear from you. But Miss Smith, no talk to me in that class period. So when me hear she are talking, me give her every opportunity. So Miss Smith, come on, mums, talk to teacher.
I have to be so extra.
Go on, honey bunches, tell me.
So if it's continuous, then it means that both sides will be equal to the square.
Say, if you don't get one A, you go shake out all your money out of your pocket.
Yeah. So you're not there really, so if you're not appreciating on
You know, no money in your pocket, I'll lie you have enough. Very, very good though. Arthur, ask me the question now.
No, sir, because you were asking her why how she get
no,
12.
okay, you answer me now. You answer me now.
Sir, as I'm saying, because it's always continuous, it says, that's why I made her come up with that answer there.
Very good, excellent. So if I say to you that the function is continuous over the interval, oh, that's what you're talking about, negative infinity and positive infinity. Yeah, man, over every something you can think of. That's why I put it like that. So if I'm saying to you that it is continuous, Cherry, I hope you're with me now. If I'm saying to you that it is continuous over all the intervals, it means, say, to the right of 1, where we evaluate the limit to be 12, it means, say, ax plus b to the left of 1 must also equals to 12, because the limits must be equal in order for it to be continuous. All right, press pause. Very good so far. We put in on that. Is there anyone in the class that don't understand what I just said?
Sir, I understand, but I don't find it as consistent.
I don't understand.
I'll copy to you. So Daniel, you say you understand, but you don't what?
I don't understand because, well, I understand, but it's not consistent with the answer I got. I got 8 to the left.
You got 8 to the left of what?
To the left of -1.
No, but we're not doing -1, we're doing +1.
For +1. The condition for the first function.
No. The first function, the condition for the first function is what, Daniel?
I got 8.
No. What's the condition for the first function?
Right. 7.
Say negative 1.
F.
No, say negative 1.
Negative 1.
Yeah. But which ones are you looking at first? Positive 1.
Looking at the last one.
Yeah. So not tell me say not understand it. It's like you saying to me, sir, don't eat KFC. Have you ever had KFC before? No, sir. You can't say no like it. Can I know it? All right. So you press pause. We soon come to that one there. Who was that? Leon, was it you or was it Dean that said that they didn't understand? Another male said that they didn't understand.
I think it was the both of us.
Okay. So you're not on what you're not understanding.
Sir, I understand I get the 12, but not how you get the AX plus B.
What do you mean? Or get the AX plus B? When a function is continuous, when I'm checking for continuity, Leon, and I'm investigating to the left and to the right, in order for the function to be continuous, what must happen?
The answer must be equal.
Hey, I thought you weren't coming to class.
Yes, I was able to come, so I just used the time to enter.
Very good. You can't frighten me them ways, you know, you just sneak up on the eye. Leon, tell Courage
sir.
thank you.
Thanks, Courage.
So
You're welcome.
In order for it to be continuous, they must be equal. Remember, you know, it has to be of a good behavior. And a good behavior something is like when you're in a yard and you know to behave yourself. And when the mother carry out a road, you know to behave yourself. You know, when I go on the road and I see a child misbehaving, stop it and behave yourself. Don't come on the road, come impress me, because if you did train that child from the child there, yeah, child can't come on the road, come embarrass you. Negative. So that there's a discontinuity right there. So when you go on the road and see a child that is well behaved, you know say a child well behaved at yard. And a child that is well behaved at school is a child that is well behaved at yard. When a child is acting out at school, don't tell me say, oh, and he's well behaved at home. Lies. There's a discontinuity there. So she's correct, Leon, that both must be the same in order for the function to be continuous. Get me, Papa?
Yes, sir.
All right.
Yes, sir.
Go ahead, Arthur.
Based on the question here.
Go ahead, honey.
Based on the question here, and the person who answers started with the 5x plus 7. Is it always that case?
In terms of what? This is always 12?
No, not the answer, because I know he input
right. Always what? Always that is starting down there, so?
Yes, sir.
No. You remember Leon, was it Leon? No. Daniel says that him start with the top one. I'm gonna tell him press pause, you know, reach yet.
Okay.
Yeah.
Okay, like X. Okay.
You know, Lucky, let me just explain this. It's like me get a nice juicy East Indian mango. I have a choice to start eating the mango from the stem or from the tip.
Okay.
Where do you start eating your mango from?
The tip.
Yeah. But some people start eating the mango from the top. And you can say you are weird.
Yeah.
But there's no manual that says when you're eating a mango, you have to bite the mango from the tip first. No. Where do you wear your watch, Lati? On your left hand or your right hand?
Left hand.
Tell me where it tells that you must wear your watch on your left hand.
No what? No.
Okay. All right. Okay. I'm just saying, right? All right. Dan, your turn. Unmute, Papa.
Sure.
All right. Good. Talk to teacher now. So you're saying something about the first equation. What? Talk to me now. What did you get for the first equation? What's the limit of the first equation?
When I've substituted -1 for x. I've got for the whole equation 8.
8. Okay. So the limit of that, so the limit to the left of 1. All right. I don't want you to in the first equation. We're going to speak the jargon. So the limit to the left of -1 is 8. That's what you're saying.
Right.
Okay. What is the limit to the right of -1, Daniel? Supposed to be equal to?
I've said 12.
Okay. What do you understand about continuity, Daniel?
That the left and the right of the function is supposed to be equal.
Then how come you tell me 12 then? 12 and 8 equals, sir?
I'm confused about that as well.
No. You are confusing yourself because let me go again. What do you understand about continuity? That
both sides should be equal.
Let's pause. Say it one more time.
Both sides should be equal.
Great. What do you get for the limit to the left of -1?
Again, 8.
Good. What should the limit to the right of -1 be equal to?
12, but I don't say how.
All right. Stop again.
8.
What do you no, tell him. Not tell him. What do you understand by continuity, Daniel?
Both sides should be equal.
Great. Work with me now. Work with me. You're correct. Both sides should be equal. What did you get for the limit of the function to the left of -1?
I got 8.
Excellent. I agree with you 100%, son. In order for the limit to be continuous, what therefore should the limit to the right of -1 should be equal to?
Should be 8, I guess.
Oh. Why?
Because both sides should be equal.
Or
but I got 12.
function. No. Don't tell me say you get 12. We're not reaching yet. Both sides should be equal in order for the function to be
equal.
So continuous.
Continuous.
All right, good. All right, thank you. I had to ask Daniel because he's giving me the correct answers, but he's trying to confuse himself. Right? Okay. So very good. I'm not being difficult. I am here to teach you and to make sure you learn. All right, watch me now. So we can look at some solutions. So you are correct, Daniel.
And Daniel is correct.
Yeah, so Daniel, you're correct that the limit to the left of -1 is supposed to be 8. You calculated it to be 8. You are correct. But in order for the function to be continuous, it says determine the values of A and B if f is continuous over the interval x is greater than -infinity and +infinity. It means it's continuous every single time. So that means that this function to the right, see here, the limit to the right of -1, see here, -1 plus to the right of -1 also has to be equals to 8. If it is not equals to 8, it means it is not continuous. But the question says to determine the values of A and B. So the question I tell you, say, make it continuous. I don't like this. This is a corny example. You know, sometimes I hear some taxi men talk about the police. I hope I don't have any policemen in my class. Forgive me if I do. I'm not offending you because I know you're the good ones. The good ones are the ones who come to Mr. Shanmat's class, right? The bad ones are the ones who never go to school or never go good school. Work with me. So sometimes I will hear taxi say, the officer asks if you're left or you're right. Anybody ever hear that yet? No.
Sir, I hear the song, but it never happened to me.
It never happened to you, right? So it means what it is that you're leaving them. So it's a jargon. It's a little slang that they are using. All right. It's pretty much the same thing that we are using here. Watch me. Work with me. In order for this to be continuous, that one you have to be equals to 8 also, because if it is not equals to 8, you would not have answered the question. If question say, if you find A and B where the function is going to be continuous over the whole interval. All right, watch me. So it means that to the right of -1, see here, x is greater than or equals to -1. That means greater than or equals is to the right. So to the right of -1, you will have ax plus b. You will have ax plus b. All right, work with me. So just like you did this one here, where Dan got 8, in this piece here, you're going to say, wherever in the function I see x, I'm going to substitute -1. Work with me. See x here? So it's going to be a times -1. See right here? Boom. But a times -1 is -a. B is a standalone, so put back plus b equals 8. Then, sir, in the other question, them, sir, you didn't get one whole number known and done. No, you will get -a plus b equals 8. Yeah. Because it just said them here unknown. They might ask you to find the unknown. All right, so we'll put up that one here. Can't work that yet. We'll go put it up. We'll try x equals -1 now. Boom, we here started 12 because we work on the bottom piece for 7. Sorry, to the right of -1. Sorry, to the right of 1, we work with 5x plus 7, and 5x plus 7. 5x plus 7. Hold on for me, please. All right, so let's go. So he got 12. Very good. So similarly, we know that to the left of 1, in order for the function to be continuous, it also must be equals to 12. So you're going to have ax plus b. Anyway, in the function we see x, we're going to put in 1 because the function is tending to 1 feature at x equals 1. So a times 1 is a plus b. So I'm going to have a plus b equals 12. All right, press pause. We are about call it halfway-ish the question. When I have 2 unknowns with 2 equations, how do I solve that? Hello, somebody?
Sir, repeat.
Say it again?
Sir, repeat, please.
I'm just saying, I have 2 unknowns and 2 equations. How do I solve it? Generally, if I have 2 equations and 2 unknowns, how do I solve that equation or those equations generally?
Sir, simultaneous equations.
We say, if it NO, you know, get one A from a course, I'm going to take my textbook and I'm going to beat you with it. And beat the calculus into your meaning. Very nice. Very nice, Dan. Keep up the good work, Papa. Actually, I'm very proud of you. Congrats, Papa. Now you'll be solving the equation simultaneously. So you have two equations with two unknowns we are going to be solving simultaneously. Very good, Dan. The rest of you, come on. All right. So now, watch my equations. My equation is going to be, negative a plus b equals 8 and a plus b equals 12. But because interstate, we are in big school, see, those are my equations. I'm calling one equation 1 and I'm calling the other one equation 2. But because we're in big school, big school, Excelsior Community College, I am not here to teach you simultaneous equations. That would have been done from little school. But let's go. I'm going to refresh your memory. Because if you know how things running now, and what sir normally do is him teach you something and then him kind of put you out into the shallow end and tell you to swim go out there. Work with me. So I'm going to be using the elimination method. So this is what the elimination method says. And most times you can use the elimination method. Most times you can use the elimination method. Most times. This is what the elimination method says. I'm looking at my terms and I'm seeing how I can eliminate one in order to solve the other. I'm eliminating one to solve the other. If I were to add both equations together, I would have eliminated my A because I have negative A plus A. When I add these are inverses. When I add these, I get 0. So this is exactly what I'm doing. I'm using the elimination method and I'm adding both equations, equation 1, equation 2. When I add equation 1 and 2 together, negative A plus A is 0. B plus B is 2B, so this is how I get a 2B right here. And A plus 12 is 20, and that's all I got a 20 right here. So I've eliminated my A's to work with the B. I want to find the value of B, so I'm going to divide both sides by 2. So this is how I get the 20 over 2. And 20 over 2 is 10. So B is equal to 10. So the value of B is 10. So I have just found B. I'm going to put B equals 10 into equation 1. Then, sir, you could put it in equation 2. If I want, I could. It really doesn't matter. And when I put it in 2, I'm going to get, sorry, I put it in 1. In 2, I'm going to get, this is 10. I'm going to subtract 10 from both sides. 12 minus 10 is 2. So A is equal to 2. So I have found the values of A and B. When the function, when A is equal to 2 and B is equal to 10, the function is continuous over the interval. Was that difficult?
No, sir.
Wasn't. All right. I want you to do this in stages for me. This is a 2010 past paper. It's a 2010 past paper. I will help you. I want you to go through the first part of the question. When you reach the simultaneous part, we will go through that. Go through the first part of the question for me, please.
Sorry, can you scroll up a bit for me, please?
Stop sharing so I can get rid of that annoying thing in front. You want me to scroll up? I will do just that. We want to go to start of the question from up here?
No, sir. The simultaneous part.
Okay, no problem.
So can I just finish right off the last part and then you can shore that, please?
Okay, no problem.
Can go ahead now, sir.
No problem. Thank you.
Sorry, I can scroll back down now.
And I've already finished this one yet. This one easy, bad. Hit that.
I reckon 3 when I finish -1.
Good job. Dean, are you with me, Papa?
Yes, sir. Still here.
Good job. Shanti, how you stay? Ashanti, yeah. You drop asleep, mommy?
I'm here, sir.
How you stay? You all right? You following?
Yes, sir.
Very nice. Come on. Come on. Not hearing you. I see you unmute, come on, but I'm not hearing you. Hearing you now. Go ahead, Papa. Don't know what is happening there. I suppose I have left. I swear. Noreen. Shani, how you staying now, mommy? Shani?
Sir, you talking to me?
Yeah, man, how you staying now?
Sir, I'm trying to do the second one.
All right, very nice. Keep it up, honey. Keep it up. Tariq, how you stay?
Working on it, sir.
Good job. Tony.
Yes, sir.
Well done.
Working on it, sir.
Very nice. Iris, how you stay?
Sir?
Yes, sir.
Sir, I'm not understanding this one.
What are you not understanding about this one?
Well, sir, it's much different from the other piece functions, because the first, well, lack of a better term, the first expression 2 does not have any x in it, so cannot determine its value.
Okay, interesting. So Daniel, let's just have a conversation. I don't want anybody to say anything because I know you know. Were you in class last week, Dan? Sorry, were you in class on Tuesday, Dan?
Well, no. Tuesday, no.
Or were you here but not here, if you know what I mean? Or you weren't here, period.
I wasn't there, period.
Maybe that's what I No, but I did that from last week, Thursday. Because when I gave it in class on Tuesday, I asked the question, it was something at 11 that I gave. And when I asked the question, somebody was, able to say to me, all right. Can somebody help Daniel for me, please? What story there is to that? Anybody, somebody, what is the story?
Sometimes the limit is a constant of itself, something like that. Is that what you're talking about?
Something like that, but it not say the right way, but something like so. So continue. What is it?
Limit of a constant is a constant
It's
itself.
constant itself.
Yeah, you said right. So if I go back to my standard right there, I say, the money right.
Sir?
Yes, Papa.
That didn't suffice. I remember.
The limit of a constant is a constant itself. So what they're saying to you, you're trying to find the limit of 2, the limit as x, the limit to the left of -1 of 2 is equals to
2, sir.
2.
So that's what I'm saying. The limit of a constant is a constant itself. So it no matter what number it is still going to be that number because that constant. You have no variable to substitute in it. So the limit of a constant is the constant itself. So the limit to the left of -1 is going to be 2, and therefore the limit to the right of 3 is going to be
-2.
Continue now for me, please. Very nice. Very nice. Continue for me, please. always do. Yes, once it is actually done, this is our second pass with a question. So mine is not the class we wanted to teach. I go through past papers as we teach. So come now, talk to finish. Hello, somebody. Talk to teacher.
I'm gonna do the simultaneous part because
Okay, all right, fine. I just want to know that you're working. All right, I give you another 3 minutes then. All right, cool. Did you get this way answer?
Sorry, can I just run through
No, sir, no, not all.
the equation?
I didn't put the
So I actually got the answer, but I didn't do it this way. It didn't even come to my mind. I got -1 for A and 1 for B, but I didn't do it like this though.
Not any problem. No problem. No problem. No problem. No problem. All right, just go. So the question says, to the left of -1, you have 2. To the right of -1, you have ax plus b. To the left of 3, you have ax plus b, and to the right of 3, you have -2. Now, to the left of -1, I'm sorry. To the left of -1, the limit is going to be 2. See here? The limit of a constant is the constant itself. The limit of a constant is the constant itself. Let me say that one more time for those who may not be here and want to access the recording. When I'm finding the limit of a constant, of any constant, a constant is just a whole number stand by itself. It could be a fractional number too. A constant is just that value without a variable attached to it. So when I'm finding the limit of that, it's going to be the constant itself. The constant itself. Not change. Matter of fact, can I answer that way, please? The limit of a constant is a constant itself. All right. So I trust that you say it. And when teacher asks if you say things you don't must say it, you know, that's what I learn. Right? So the limit of a constant is the constant itself. The limit of a constant is the constant itself. Can't change, will never change. The limit of a constant is the constant itself. All right. So I'm finding the limit of to the left of 1, of -1. And the function is just 2, a constant. The answer will be 2. The limit of a function of a constant is a constant itself. But guess what? To the right of -1, I'm going to have ax plus b. To the right of -1, I'm going to have ax plus b. No problem. In order for this function to be continuous over all the values, see? The function to be continuous on the entire real line. That's another way of writing x is greater than -infinity, but x is less than positive infinity. Over the entire real line, over every single something per number line, you want it to be continuous over. It means that to the right of -1, you're going to have ax plus b. That must also be equals to 2. And since I'm to the right of -1, anywhere in ax plus b equals 2, I see x, I'm going to put -1, substitute -1. See there? A times -1 is -a. Boom. Plus b. And that is equal to 2. So this is my first equation. Anytime you get one question like this, Papa.
Sir, where I get getting mixed up, sir, is where the b is. Sir, where the b is, should we substitute it with the 2? Because I keep getting mixed up right there, sir.
Let me ask a question, Papa. You see no hex beside the b?
No, sir.
You can't substitute nothing again. You can't substitute nothing. There's no hex there. You see a hex beside the hay?
Yes, sir.
Say, yeah, man. So it means, wherever the limit is tending to, I'm going to assume x is equal to that number, then substitute it in the yeah.
Okay, sir.
But b in this case is going to be a constant. So I don't have nothing to substitute, so I'm going to leave it alone. You get that?
Yes, sir.
All right, good job. Let's go. Now I'm going to look at the last piece first. And of course, somebody asked a question and I didn't answer it just yet, but let me just highlight it. So yeah, you notice in the first question I started with the bottom piece down here, so. But Daniel says, sir, I started with the top piece. Not a problem. So I can start either at the top or I can start at the bottom. Because whatsoever the top equal to, remember say, a middle piece is supposed to equal to it too. And with the bottom equals to, remember say, the middle piece is supposed to equal to what don't say equal to, in order for it to be continuous from yaso to yaso and from yaso to yaso. All right? We're looking at continuity. It's supposed to be continuous on the entire real line, not piece of the line, but the whole of it. Let's go. At x equals 3. To the right of 3, to the right of 3, the limit is going to be 3 because the limit of a constant is the constant itself. The limit of a constant is the constant itself. So boom. We said 3 a while ago. The limit to the right of 3 is going to be equal to -2 because the limit of a constant is a constant itself. See it yourself? There's no there's no variable for me to substitute the 3 into. So we're going to leave it alone. I'm just write the 2. Watch this now. To the left of -3, or to the left of +3, sorry. To the left of 3, I'm going to have ax plus b. To the left of 3, I'm going to have ax plus b. That must be equal to -2 if f of x is going to be continuous over the whole line. Over the entire line, it must be equal to that. So what I'm going to do is to say x plus b is equal to -2. Wherever in the function I see x, I'm going to substitute 3. So watch it now. A times 3 is going to be 3a plus b equals -2. Now I have my second equation. You notice this and this are equal, and I put them in color so you can see it. And the 1 here and the 1 here equal. Why, sir? Because it is continuous over the entire real line. Now we're solving simultaneously. And again, I'm going to use the elimination method. And trust me, these are my equations. -a plus b is equals to 2, and 3a plus b is equal to -2. And I'm solving that simultaneously. What I'm going to be doing, I recognize that a is a negative and b is positive. So all I'm going to be doing is multiplying the first equation by 3. I'm just multiplying by a scalar quantity. So I can carry it over what it is that I want. I'm multiplying by a scalar quantity. So I'm multiplying through the equation by b. By 3. By 3. So this is going to be 3 times -8 -3a. 3 times b to give me 3b, and 3 times 2 to give me 6. So there is, are you hearing me?
Sorry, we're breaking up.
Yes, sir, we're breaking up already.
I just saw that my internet is unstable. That's why I stopped speaking. So what I'm saying to you is, I'm solving simultaneously. So because this a, sorry, let me spotlight. This a here is negative, and this a here is positive 3. In order for me to eliminate, because I'm using the elimination method and I'm eliminating the a's first, I'm going to multiply equation 1 by a scalar quantity 3. I'm multiplying equation 1 by a scalar quantity 3. So 3 times all of this is going to give me -3a plus 3b is equal to 6. I'm no longer interested in equation 1. The equations that I'm not interested in are 2 and 3. Then so I cannot show equation 1 like that, man. Equation 1 is not a multiple of equation 3. Equation 1 is a multiple of equation 3. I don't need it.
I'm sorry, please, can you repeat that? Sir?
Equation, are you hearing me? I think I'm breaking up. Are you hear me?
Yeah, I can hear you, sir.
Right. I'm just saying to you that equation 1 no becomes a multiple of equation 3, or equation 3 is number 1. Why, sir?
Are you breaking up?
Breaking up, sir.
Hold on there. Name of Jesus, stop it. All right, tell me if you hear me now. Hello? Hello?
Yes, sir, we hear you.
All right, good. Sorry about that. I don't know what is happening. Maybe it's all right, let's just see how quick we can just go through it. When I finish this one, I will just call it off, right? And then I will send you, that's what is at the bottom of this. If I have another question, I'll send it out to you so you can do something for me. So what I'm saying to you, equation 3 is now a multiple of equation 1. Equation 3 is 3 times equation 1. It's just a multiple of it. Why did I increase it by a scalar quantity? So that it now becomes easier for me to add equations 1 and 2 to eliminate my a. Look at this here. This negative 3a plus this positive 3a is going to go to 0 when I add them. Talk truth.
Yes, sir.
Every single time. 3a minus 3a is 0. Minus 3a plus 3a is 0. So now because I'm adding both equations, you know. So this goes to 0, and then 3b plus b is going to give me 4b. And then 6 plus 2 gives me 8. So now I have a simple equation. Dividing both sides by 4, b is going to be equals to 1. Dividing both sides by 4, b is going to be equals to 1. Now that I have found the value of b, I'm going to substitute it into any of the 3 equations that I have up here. So no, 1 or 2 or 3, in order to calculate the corresponding value of a. Doesn't matter which equation. So I've chosen equation number 2. So anywhere in equation number 2, I see b, I'm going to substitute 1. There goes a b. So this number comes 3a plus 1 equals negative 2. Watch me. This is 1. When I subtract 1 from both sides, I'm going to have 3a is equals to negative 2. See this positive 1, when I subtract it, it becomes negative 2 minus 1. And minus 2 minus 1 is negative 3. I now have a simple equation here again. Dividing both sides by 3 is equals to negative 1. So therefore, a is supposed to be equals to 1 for this function to be continuous over the entire real number. Question.
Right, sir. My brain. That's right.
And that's fine, you know, because let me tell you why it's fine. What I am confident is a fact that for the most part, you all know how to do the piecewise function. What is not giving you a little trouble is the simultaneous. I mean, that is the time to go through the simultaneous. Which brings me, and I'm wrapping up. Which brings me to this very salient point. Whenever Mr. Shan comes to class, he's always going to be building on what was done in the previous class or classes. Case in point, we looked at piecewise function last Tuesday this week. Still last Tuesday. We looked at piecewise function. And for the first half of the class, 3/4 of the class, what it is that we looked at was still piecewise. But I'm increasing the difficulty level of the question now by putting some unknowns inside here. Marking. it is done exactamente. The same way we did the first one is the same way we're going to do the second one. It's just that when we have unknowns, and when I have two equations and two unknowns, I can't use a linear algebra to work with. It has to be simultaneous. Problem is, I think there's a disconnect between the simultaneous equations for now, but fret not, we're gonna get there. All right. Are there any questions?
Yes, sir.
Go ahead.
Yes, sir. I was curious to know how you got the same answer by another method, because I reached at the where you should eliminate A, but I did not know where to go from there. So you had told me to multiply it by 3 and create a third equation, but I did not know that. But what was method 2?
So method 2 is me recognizing that the b's are the same, and if I subtract one from the other, I get them to be 0. So I'm subtracting equation 1 from 2. When I say subtract 1 from 2, it means that we have 2 minus 1. When I subtract equation 1 from 2, and I write it on paper, one from 2, it means there's equation 2. Oh no, that. That's a shame. Right, so what I have now is, so I'm subtracting 1 from 2. So I'm subtracting equation 1 from equation 2, so 1 here. So what I have is 2 minus 1. So what I'm going to do is look for equation 2. I'm going to look for 2. Then, comma, then subtract 1. So equation 2 here, this is 3a minus a negative a becomes 3a plus a, which is equals to 4a. And then
And sir, what happens to the B?
b minus b is equal to 0.
So you multiply the first equation by -1.
I have to multiply in, yeah, technically I'm multiplying the first equation by -1.
Oh.
Yeah. Right? So you could look at it like that. And then instead of subtracting now, it's going to be an addition. All right? But let us continue with the subtraction. You see, I keep telling you that there are several ways to skin like that. Many, many ways. All right, so let's go with this. Let's continue in this way. So B minus equation 2, you have to keep the format. Because subtraction is not commutative. Addition is commutative. Because I can say 2 plus 1 is 3 every single time, and 1 plus 2 is 3. If I say 2 minus 1, I'm going to get positive 1. But 1 minus 2 is a negative 1. So subtraction is not commutative. So I have to be very careful when I'm dealing with my subtraction. Very, very careful when I'm dealing with my subtraction. All right, so let's go. It's going to be -2. Second equation, -2 minus 2, which is a -4. This -2 minus 2 is going to be -4. Divide both sides by 4. Divide both sides by whatsoever is in front of a to find a. So I'm going to get x to be equals to -1. And when I substitution into equation 1 or 2 or 3, anywhere in the equation I see x, I'm going to put in my 1, sorry, my -1, I'm sorry. And when I say a, I'm putting my -1. 3 times -1 is -3, plus b is equal to -2. So I have -3 plus b is equal to -2. I want to isolate. I want to keep this one. I want to keep b. So what I'm going to be doing is, this here is a -3. I'm going to add to both sides +3. I'm going to add a +3. I'm going to add what I do with one side and to the other side, it nullifies it. It nullifies it. I owe Lottie $15,000 Jamaican dollars. Lottie said, "Well, sir, you get on my face and I need to look by one tire." I was about to say 2 tires, but clearly $15,000 can't buy 2 tires. So we need to go buy a tire, sir. So we need some money. So all right, let's get it back. You know, I have no Jamaican here, but let me give this $100. Do you think all of that splits out now? Me owing her $15,000 and me giving her $100 US. I think that splits out. Question. Are you guys hearing me? Are you guys awake? Are you guys there? Or I am?
Yes, sir, we're here.
We're here, sir.
Come on, so answer me now. I'm saying to you, if somebody owe you $15,000 and you say this money, I say, I want my money now, come on, buy one tire. And the person said, I don't have $15,000, but it's $100 US there. I'm asking the question, do you think that it will squeeze out?
Yes, sir. That's $100 value, about 15,000.
Yeah, about $15,000, yeah. So that's the point I'm making here. So I'm going to add 3 to both sides. So when I add 3 to both sides, this and this cancel, and I'm going to have -2 plus 3 is going to be equals to 1. So b is going to be equals to 1. So what I'm going to have would be my my a to be equals to -1, and my b is to be equals to +1.
So, sir, you have -3 right there. You have to cancel. Could you not just bring over
all right, so
the negative positive three?
And then okay. So based on what you just said, well, I can't even repeat it. Based on what you just said, well, you know, it's on the country people don't say bring over, you know, it's like Leon come from country, you know, so you know we talk about the bring over part.
I'm from
right?
country.
But, that's what you talk about bring over. All right, Leon, we can leave you alone. You can talk to Arthur from country. All right, no, Arthur, you see, when I was going to look at school, that's what my teacher taught us. Carry over the equal sign, the number changes. And then no, when we go big school and they said to me, go to a teacher, and I sat down and I listened to it. I said, but me can't take up the number out of the paper and carry it run away. The number is fixed on the paper. How do I remove it? It's by looking at the inverse. And let me tell you when that came alive for me. When I was doing the same simultaneous equation using a matrix method, where it is that you can't divide in matrices. The closest you can do with a division in matrices is by finding its inverse. So I'm finding the inverse of -3. The inverse of -3 is +3. It's just the opposite of it. So I'm just adding the opposite of the number to both sides.
Okay.
And a succumb teacher author said you carry it over the equal sign, but nowadays, hey, when they look at grade 3 pick me I do it in a mathematics, you know. I must about first or second family learn them something. I see one grade 3 book there they talk about vertex and vertices. Hello. My teacher in a foundation concept 3. Vertex and vertices, and I was called to come and explain what is a vertex. He said, man, Collywog. Yeah, man. So that's what it is. All right. Here's a quick question that I need to ask. I know I'm tired. I too am tired. I had a 2 hour before this one, so I'm going 5 hours now. So I'm a little tired myself. Let me ask you a question though, and I want your honest feedback because I have a little concern, and I really am not one who is going to wait until the first run through the gate. Then I say, geez, I should have done something. Are you understanding my style of teaching online? Do you think that you're learning? You don't have to like me. That's not even a part of the problem or question. Just answer. Do you think my method of teaching online, preparing the notes ahead of class and its solutions and projecting them in class? Because inevitably, when you watch the recordings, you see all these notes, right? You see everything. And uploading the recordings and, trying to set up the WhatsApp group to get everybody together. What can I do different? Are you learning based on my methodology? If yes, how can I improve on it? If no, what must I do in order to make the experience a little bit better? I give you 2 minutes to talk about this quickly. Anybody, somebody.
Oh, sir. Could you get a different mic?
Thank you very much, sir. I will definitely try and do that. Anybody else?
No, sir, I don't have an issue with the methodology. It's okay.
All right, thanks, Leon. And guess what? Enough of feel free to know. If you don't like it, you must tell me now. I say, sir, reel and come again. Find a different methodology. Because me under that team. Let me know. Because I need to go to the table and bring back a newness to what it is that we're doing. So talk to me. I need one other person to talk to me. And if I don't get you, I'm going to call upon somebody. Hello? All right. So
the methods are clear, they're very clear. It's just a thing I need to work on my little school math somewhat.
Okay.
So
Fair
yeah.
enough. And I don't have a problem with that part. And if you recognize what I did today in class when you guys were afraid of the fractional question, you know what I did? I step aside. I present the material, I step aside, and I'm going to be very honest with you. You go look at a little team. Let me step aside. All right? Because I wanted you to get an opportunity on your own to look at your errors. And when I came back, you know what was said to me? Sir, I see it. And Atara, who never talked to me before, said, sir, can I ask a question? Where the x minus 1? Where the negative 1 go again? It's not Atara. It's not Atara. Is Atara? Who was it? Somebody. When nobody talking to us. I said, sir, we don't know how you get. I want them to say, that's so get it. So thank you. I still, for me, I still require a little bit more conversation so that I can know what is in your headspace so I can help you more. If I don't hear from you, I am not going to know what you're thinking about. And what you're thinking about is what you're holding on to for dear life. And it may or may not be correct. And God forbid, if it is incorrect, you're going to reproduce that incorrect stuff and you can fail the course. And I don't want anybody to fail the course. I've taught this course before where everybody get 100% pass. No lie. I've taught this course where everybody passed the course. Not everybody get 100%, but everybody passed the course. And I really want this to happen again. All right, so please work hard.
That would be 100%.
No, but how I said it, it sounded as if everybody got 100%. It's me that got the 100%. Yeah. Bless your heart. Yeah. Bless your heart, guys. Sleep tight, study hard. All the best. Thanks for coming out.
Thank you, and same to you, sir. Good night.
Awesome. Good night.
No, sir.
Good night.
Thanks.
Good night, sir.
Night, sir.
Good night, sir.